Okay, so this next topic is numerical integration, which is all to do with finding areas in the curves. So for example, if I give you this curve and asked you to find the area here, you could do that by integrating 2 to 5 of x squared and you get the exact area. Now, sometimes there's equations where we don't know, where we can't integrate. So something like this, or it's going to be very, it looks more like that. This curve, for example, I equals x to the power x. If we wanted to integrate that between 2 and 5, we can't do that using algebra. The only way to do that would be what we call numerical integration. So there's two techniques for this. One is using rectangles. So we would split the area up into rectangles, work out the area of the rectangles, and that'll give us an estimate. And one where we would use trapezium, and that's going to turn out to be a better one. So you should have either written out the handout or printed it out, so we can start on it. So today we'll do the rectangle method, and then tomorrow we'll do the trapezium method. Okay, so using the rectangle method, we're able to get two different values. One, by drawing rectangles under a curve, that'll give us what we call a lower bound, and one for drawing rectangles above the curve, so that'll give us an upper bound. So we know that the area would be bigger than this estimate and smaller than this estimate. So let's have a go at working our way through it. So the first thing we need to decide is how many rectangles are we going to have. So the question would tell you if it was in an exam. Then once we know how many rectangles, we need to work out what will the length of a rectangle be. So here in this example, you can see that we're integrating between 0 and 1. That's 0 and 1 of e to the minus x squared, and it wants 5 rectangles. So what we need to do is we need to work out the length of each rectangle, or we call it the height, because we imagine the rectangle on the side. So to do that, we need to work out what the big distance along the bottom is. So we would do 1 minus 0. That's how long it is, that's just 1, and you'll see why I'm doing this, not just writing 1. I want to divide it by how many rectangles I want. So I divide by 5, so I get the height of each rectangle, or the height at the bottom, the h we call it, should be 0.2. So can you see it goes up to 0.2, look, 0.2, 0.4, 0.6, 0.8, and 1. Then what we need is we need the values at these different points. So I'm going to draw a table. X and Y, 0, 0.2, 0.4, 0.6, 0.8, and 1. Now, to get the Y values, I can just sub these numbers into there. There's no harm in doing that. However, your calculator will do this quickly for you. So, to show you how to do that, it's on the menu, go on to table, so number 7, and it should just look like a graph menu. Then we're going to type in the function we want. We want e to the power minus x squared. And then before we click table at the end, we're going to click set, just like we did with the sequences. And we're going to tell it where to start and end. So we start at the bottom, so we start at 0. We're going to end at 1. And the step, that just means how many numbers do we need. Going up in 0.2, so my step is 0.2. And then if I press table look, it'll give me all the y values. And in fact, it's also giving me dy by dx, which we don't need for this question. So ignore that last column if yours shows it. So I'm just going to fill them in. So it's 1, 0.9607, 0.8521, 0.6976, 0.5272, and 1. Sorry, why did I say 1? Read the wrong number 0.3678. So I've got all my y values. Now, this next bit is probably the trickiest bit. Just working out which ones do we need for the lower values and for the upper values. So if you look here, when I'm drawing the rectangles underneath, this height of the first rectangle is actually 0.2. Let's have dots on the ones I need. I need 0.2, 0.4, 0.6, 0.8, and 1. I don't actually use 0, look. So it's these ones here will give me the lower bound. Whereas if I look where I draw rectangles above, I use the value 0, I use the value 0.2, 0.4, 0.6, 0.8, but I don't use that value of 1, look. Can you see the rectangle isn't there? So that 1 would be used for the next rectangle. So it's only the first ones that I used for the upper bound. Yes, so it's always good to draw a sketch because this pattern could change depending on if it's convex or concave. Yeah, so it's usually you miss out the first one and miss out the last one, depending on if you want upper or lower. So draw a sketch to see. So just to go through that again. So you look at that first rectangle, and if I draw it underneath, it's the second value I want. I didn't want the first one, look, it was the second one. So I start at the second one for the lower, and for the upper one, look, I do want to start on 1, but if you look, the last one is the one I don't want. So I ignore the last one for the upper. Okay, then to get the area, well, what we would do, look, I'm going to do this on a whiteboard so I can rub it out. I would do, well, for that first rectangle, it will be 0.2 times, let's call that, I call that y0, y1, so I times that by y1. Then for the second rectangle, it would be 0.2 times y2, 0.2 times y3, etc. Okay. Then I'm going to add them all up. However, when I add them all up, look, what I could do is I could factorize out the 0.2 and just add together the y values. So what I'm trying to get at is if I want to get the area of all the rectangles together quickly, all I need to do is add together the y values. So for the upper, I would add together these 5 y values and then just times it by h. So for the lower, let's do it up here, actually down here. So for the lower, it would be 0.2 times 0.9607 plus 0.8521 plus 0.6976 plus 0.5272 plus 0.3678. Yeah, and then you just go on to your calculator mode, just type it in. So 0.9607 plus 0.8521 plus 0.6976 plus 5272 plus 3678. And that will give me, and we want 3 significant figures, so that gives me 0.681. And do the same for the upper. So 0.2 times the upper was the first 5, so 1 plus 0.9607 plus 0.8521 plus 0.6976 plus 0.5272. So all I'm going to do instead of typing it again, look, I'm just going to put a 1 plus the front, because 1 was the first one, and then delete that last one on my calculator. And we get 0.808. So we know that our answer has to be less than 0.808 and it has to be bigger than 0.681. So I can write it as an inequality, look, it's an 8. It's not for pretty much like an 8. It's just that number there. It's bigger than the lower bound and less than the upper bound. And then to double check, what you could do is just type it in here, look, because your calculator will be using probably the trapezium rule to work this out. So that's what we'll look at tomorrow. So there you go. So that's an accurate estimate for the area. So 0.746, it's in the middle of those two numbers. So this method does actually work. Yeah, the thing you have to remember is to find which of these numbers do you ignore for the upper, and which one do you ignore for the lower. So let's try another one. And that there is just a little demonstration of what I was trying to show before. This delta x, so that's a Greek letter delta, that just means a little bit of x. So that's why I called h before. So the reason we're calling a delta x in this example is because it's going to turn into something. So if you look here, this diagram, so we're going between a and b, delta x, and these are the different y values, look. So to get the area, we would add all the y values and times by delta x and times by h. Now what would happen is, if we take more of these rectangles, then the bound would get closer to the real value, so the actual area. So if we take the infinite number of rectangles, that's what this thing here means, as n goes to infinity, then this sum, so all the rectangles added together, will actually equal the integral. So that's basically the definition of an integral. Is it's as the rectangles get smaller and smaller and smaller, so you get an infinite number of them, then the sum actually becomes the area. So it's a bit like first principles for differentiation. Okay, so all you need to be aware of is, if you see this notation, so the y values times by delta x, and delta x, it just means h. And we'd write it like that, because look, delta x turns into dx, so it's easy to spot what happens. So in the exam, if they say that, it just means integrate it. It doesn't mean split the area up into an infinite number of rectangles. If it gives you a specific number there, like 4, then it means draw the rectangles. Or in the example we're going to do, it will mean that. So we've got another example here. So the area under this curve, x cubed equals 3x plus 3 between 1 and 2, it's estimated using the areas of 8 rectangles of equal width delta x. So again, that just means h. So on that picture, the first thing to do is, what is the value of delta x? Well, we're going from 1 to 2, so the difference there, take them away, and we're splitting it into 8 rectangles. So it's 1 over 8, or 0.125. So that's the width of each rectangle, or the height, as we call it at the bottom. The area of the smallest rectangle can be found by y1 times dx, where y1 is the height of the rectangle. Calculate the sum from 1 to 8 of y times dx. So that just means work out the area of all these rectangles added together. So we're going to need to make that table. Now, I'm not going to fit it vertically this time, so let's do it horizontally. So I need 1, 1.125, 1.25, 1.375, 1.5, 1.625, 1.75, 1.875, and 2. I'm just going up by 0.125 each time. Then to work out the y's, so again, I could sub each of the x's into there, but that's going to take ages. So instead, I'm just going to go on the table. I'm going to delete that, put the new one in, x cubed, take away 3x plus 3, and I'm going to set it between, I'm going to start at 1, go up to 2, and I'm going to go up by 0.125, draw the table, so there's all my answers. So it's 1, 1.0488, 1.2031, 1.4746. Oh, didn't leave myself much room for this one. 1.875, 2.416, 3.1093, and 3.9667, and 5. Okay, then we need to work out which ones do we not, or which one do we not need. So So I'm going to put dots on the points that touch it. So that one, 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 that one. It should be 8 because it's 8 rectangles. And so I needed 1. And look here, this one's number 2. I don't need that height there. It was this one I needed. The height for number 2 would be up here, so it'll be the next rectangle. So these 8 numbers I need. So to get this answer here, it's the height, 0.125, times by these 8 numbers added together. So 1 plus 1.0488 plus 1.2031 plus 1.4746 plus 1.875 plus 2.416 plus 3.1093 plus 3.9667. So go back on your calculator to add them all up, and you can see the biggest mistake people do on these questions is they type something stupid in the calculator by mistake. It's so easy to do, like I just did there. So 3, ignore my bad handwriting, 1.4746, 1.875 plus 2.416 plus 3.1093. What happened there? 093 plus 3.9667. So we get 2.0116, blah, blah, blah. Now, can you see these have all got 4 decimal places? So I'm going to round it to, let's do 3 decimal places. Okay. Now, I'm not going to work out the exact area in my calculator because I think that's when the next part of the question is going to ask me. So it says, a more accurate estimate of the area under the curve can be found using more rectangles of smaller widths. So again, that could be one more question. How could you make your answer more accurate? Well, increase the number of rectangles, which means decrease the value of h, the width of the rectangles, the height of the rectangles. So calculate the limit as n goes to infinity of that. So that just means I'm going to integrate y between, it was 1 and 2. So we're going to integrate between 1 and 2 of x cubed, take away 3x plus 3. Yeah, remember, if it is infinity, that means that's an integral. Then we get 1 over 4x4, take away 3 over 2x2 plus 3x between 1 and 2. Submit 2 first. And then sub in 1. I'm going to do them separately, so I'm going to sub in 2 first. That gives me 4, and this one gives me 1.75. So take it away gives me 2.25, which if you look at the estimate, it was close. So this one would have been the lower bound because all the rectangles were underneath. So this number should have been lower than that, and it was. Okay, so you're going to practice some like that now. So try and use that table function on your calculator. I think you should have it on this one. So I know that some of you still use this one. Let me just see if I can find it. Table, and then let's see if it will work. So it was x cubed, take away 3. It's 3x, wasn't it? Yeah, 3x plus 3. And we're starting from, it was 1, 2, and the step was 0.125. There you go. So you can still use this to get all your numbers as well. Okay, any issues, just give me a message. And remember, if it says infinity, if you've got an infinite number of rectangles, that just means the integral.